All right, so we have something to go over still from long division. But still 3.2. Okay, so this is 3.2. There is a problem like this on your quiz, so I want to go over it. We did one like this on Friday, but this is just kind of the wording that you'll see on your quiz. So this is a more specific example for that. So it wants me to show that x plus 4 is a factor. So since it tells me it's a factor, what do I know will be true? Yep, the remainder will be 0. Okay. It says use long division. So I'm dividing by x plus 4. And my divisor, x cubed plus 4x squared plus 9x plus 36. Make sure there are no skips with your exponents. 3, 2, 1 constant, so you don't need to put a 0 there as a placeholder. Okay. So what would you need to multiply x by to get x cubed, x squared? And then we distribute, so that's x cubed plus 4x squared. And subtract down, subtract both terms. So 4x squared minus 4x squared is 0. Okay? Bring down your 9x. So that's plus 9x. Okay, you can either write 0x squared here and do, okay, what would you multiply x to get 0x squared? Well, 0x, put a 0 there. But since it's just 0, you can ignore that 0 and go ahead and bring down both terms. Okay, because you need 2 terms. This has your divisor, x plus 4 has 2 terms, so when you're dividing, you need 2 terms. Okay, so what would I multiply x by to get 9x? 9. So I'm going to put that over here. So I just basically don't have an x term. So that's 9x, and then 9 times 4 is 36. Okay, subtract down. 36 minus 36 is 0.
Do we have to show that the remainder is 0? Like, for completion points or something? Or
Like to put a 0 here?
Just, like, yeah, can we just cancel it?
Yeah, if you just cancel it, that's fine. Okay. Yeah. But I at least want to see that part, so you know that you do that 0. Okay, and then it tells me to write it as dividend equals divisor times quotient plus remainder. So that's x cubed plus 4x squared plus 9x plus 36 equals divisor, which is x plus 4, my quotient, which is x squared plus 9, and then my remainder is plus 0. Okay? Okay, now we're going to take that and write the complete linear factorization of f of x. So that means we're going to write f of x in factored form. Okay, well, what do I know one of the factors is? X plus 4, it tells me in that first line, it says show x plus 4 is a factor. So one factor is x plus 4. And when I divided by x plus 4, I got x squared plus 9. So that's my other factor, but it says complete linear factorization. Is x squared plus 9 linear? No, so I have to factor that more. So I'm going to talk about that. Okay, so x squared plus 9 is sum of squares. If it were x squared minus 9, what would that factor to? X plus 3, x minus 3. When it's sum of squares, it factors the same way, except these become imaginary. So this factors to x plus 3i, x minus 3i. You cannot have I when you graph, but we're writing the factors. We're not graphing right now. So, but that's important to note because it'll affect these answers down here. Okay. All right, but it still can factor, even though it's imaginary. It still can factor. But let's just practice another one. So, what would x squared minus 16 factor to? X plus 4, x minus 4. So if it's difference of squares, then you have real numbers. But if it's sum of squares, then what would it factor to? 4i minus 4i. Okay, so we looked at that, but it's been a while. It was, I think, back in the review chapter. We talked about it when we were doing all of that factoring. So it's been a while. Everybody okay, though, with how to factor these now? Okay. All right, so then our next step is to write the real zeros of the function. So the zeros are where we would set it equal to 0 and solve. So these are the factors here. These are the factors. Then the zeros would be negative 4, because we're solving, negative 3i, and positive 3i. Okay, those are just the zeros in general. This question asks me for the real zeros. Are all three of these real? No. Which one's real? So this one only has one real zero. So you don't have to write these two. I was just writing them there to show you. You just need to write the negative 4. So x-intercept. We don't graph imaginary numbers, so we're not. These are not negative 3i and positive 3i are not x-intercepts. So x-intercept is the 0, but written as an ordered pair. So negative 4, comma 0. Okay, questions about that? All right, that will be on your quiz tomorrow. Okay. Now we're going to talk about synthetic division. Okay, an important note is this right here. So factors are used for long division and zeros are used for synthetic. So my factor is x minus 4. That means my 0 is 4. So with synthetic division, I'm using 4. Okay. So that's what I'm dividing by. I have like this upside down division, but I have two columns here. So I'm going to put just the coefficients, so just the numbers in front of the variables. So 5 negative 17, and negative 12. Make sure there's no skips. You would need to put a 0 as a placeholder, just like long division, if your exponent skips. Goes greatest to least. Okay. So what we do is you have to bring the first one down to get started. So this becomes 5. And then you take this number here and multiply it by your 0. So 5 times 4 is 20. And then add down. So long division, subtract down. Synthetic division, add down. I mean, think about how it's the opposite. How long division, you use the factor. Synthetic division, you do the opposite and use the 0. So instead of subtracting, you're adding. Okay, so that's positive 3. 3 times 4 is 12, and negative 12 plus 12 is 0. Okay. So this last number is always your remainder. Then to write your answer, start here. Start with the number next to the remainder, because that's constant. So it goes constant and then x. If there were 3 other numbers, it'd be constant x, x squared. Right, so you just go least to greatest, but starting on the right. So this is 5x. That's a positive 3, so plus 3. Since there's not a remainder, this is my answer. 5x plus 3. Okay, let's practice another one. So synthetic division is dividing by linear polynomials. So that's the only way it works, is by just the linear factor. That's why we have long division, because if I wanted to divide by something bigger, like a quadratic, I'd have to use long division. Okay, so my factor is x plus 2, so that means my 0 is negative 2. Okay? So I'm dividing by negative 2. Look at your dividend, see if you have skips, 3, 2, 1, constant, so I'm okay there. What's the coefficient in front of x cubed? What about x squared? Negative 5, good, then it's negative 11, positive 8. So bring the 1 down to get started. One times negative 2 is negative 2. Add down, so that's negative 7. Negative 7 times negative 2 is positive 14. Add down, so that's 3. 3 times negative 2 is negative 6. Add down and you get 2. So that's your remainder is 2. Okay? So starting with this 3, that's constant. And then negative 7 is x, and then 1 is x squared. So I have 1x squared minus 7x plus 3. Okay, and then I got to write my remainder, so plus 2 over my original factor, which was x plus 2. My original factor is x plus 2. Okay, so this is how we'll write our answers for synthetic division. So the long division one on the quiz tells you to do the dividend equals quotient times, or divisor times quotient plus remainder. The synthetic division one does not say, so we're going to write it in this form. Yes. Yes. Okay? Yes.
Are we going to be good for
Like long division and synthetic division, or?
no, like the Jewish chapter?
Yes, because, so there's the way for long division, and it will tell you, okay? And then this is the way for synthetic division.
Isn't there a way to do it on division?
Yeah, this is the other way for long division. So you could write both of them, synthetic and long. You could write them both ways. It's possible. Yes. Okay? All right. So the reason why this says tricky is because you have to remember your placeholders, your zeros there. So I'm dividing by x plus 3, so for synthetic division, that means I need to use -3. Okay? And then I have 1x to the 5th minus 13. Okay? Finish filling that out. Be careful. Remember, you have to have every exponent accounted for. And then I have 0x cubed and 0x squared, negative 120x, and positive 8. Okay, I want you to work this out. You do get a large remainder, okay? So that doesn't mean you're doing something wrong. Oh, yeah. So this should go here. And add that with 8. Negative 930. Oh, okay. Should go here instead of that. That's it. Okay, so let's just check. Looks like most of you were getting it. Be careful with big ones like this. It's easy to make calculation mistakes. So that's 1, -3. So double check, those of you that I didn't get to see, what you had as your final answer. Negative 144 times negative 3 is positive 432. Okay, so then when I write my answer, so here's remainder. So 312 is constant. Then I have x squared, x cubed, x to the fourth. So 1x to the fourth minus 16x cubed plus 48x squared minus 144x plus 312, and then plus, or you could write minus here, but negative 928. So if you wrote a minus here, then you wouldn't put the negative here. Over your original divisor, which was x plus 3. Okay? Questions about that? Okay. So if it didn't give me directions and it just said find g of 2, what would you do? Yeah, you just plug the 2 in for x. So that's how we'll verify using another method, just direct substitution, plug 2 in for x. But we can do this using synthetic division. When it's given to you like this, that's already the 0, so you're not doing the opposite. You only do the opposite if it's with x. If it's not with x, then you don't do the opposite. So you're just going to do divide by 2. So that's 1x to the 6th. Okay, then what would I have after 1? Good, 0x to the 5th. Negative 4x to the 4th. And then 0x cubed. 3x squared. 0x. And then 2. Okay, so practice this one again. This one, you do get a remainder, but it's not really big. Yes. Okay, so then I get 2. So I should get a remainder of 14. So this question isn't asking me to divide these and write the quotient. We can go ahead and practice that. So I would have constant is 6, 3 is x, and then x squared is 0, x cubed is 0, 2x to the 4th, 1x to the 5th. So x to the 5th plus 2x to the 4th, and then 3x plus 6. And then when I do this part, since it's g of 2, when I put it with x, then I have minus 2. Okay, but it's asking me to find g of 2. So the remainder theorem, we talked about that on Friday. So the remainder theorem says g of 2, when you plug this value in, it's equal to your remainder. So g of 2 equals 14. So really all I needed from this problem was the remainder, was 14. So you don't have to write this part here for this problem, because it's wanting me to find g of 2. Okay, verify using another method. So plug in for x, how we would do this if we didn't have directions to use synthetic division. So this is on your quiz tomorrow, so if it says use synthetic division, you do have to show this work, the synthetic division.
So to show the work for verifying it, would you just write down and put in the two?
Yep. To show work for verifying it, show the substitution, and then the rest can be done on your calculator. But really do check it. Don't just, you know it should equal 14, but don't just assume that it does, because maybe you made a mistake up here. Okay? Questions about that? All right, we have one more thing to look at in this section. We're going to do 2 examples over it. So we're going to be kind of working backwards now. We're going to be given the zeros, and we're going to write the polynomial. I'll give you a minute to write it down. The directions might seem a little confusing, but this really isn't difficult. Okay, so all I'm doing is writing a polynomial. So we'll write it in factor form first, so that's the easy way. So I'm going to call it p of x, p for polynomial. These are the zeros. Degree 3 means you should have 3 zeros. Okay, I do. So if my 0 is 1, that means my factor is x minus 1. Okay, and then if my 0 is negative 4, my factor should be x plus 4. And then if my 0 is 2, my factor should be x minus 2. Okay, that's factor form. Standard form, this means you need to multiply that out. Okay? So when you multiply 3 binomials, just take 2 of them and FOIL them first. So you could do the first 2 or the last 2. So x times x is x squared. My outer is 4x, the inner is negative 1x, so that gives me positive 3x. Negative 1 times 4 is negative 4. Okay? And then I have to do that times x minus 2. Remember, when you multiply a binomial times a trinomial, distribute the parts from the binomial, so both parts. So I'm going to do x times x squared and 3x and negative 4. So that's x cubed plus 3x squared minus 4x. And then I'm going to take negative 2 and do the same thing. And you can line it up underneath and add down adding your like terms. We did that. Or just stick it on at the end. It doesn't really matter. Okay? So then combine your like terms, and we're done. So x cubed, 3x squared, and negative 2x squared gives me 1x squared. Negative 4x and negative 6x gives me negative 10x, and then plus 8. So that is a polynomial of degree 3, because it's x cubed. And when we factored it, it factored to this here in red, which gives me these 3 zeros. Yes. 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 So, on your quiz tomorrow, you have to do this, but it just wants you to do it in factored form. Okay, so really easy tomorrow, just writing it in factor form. Okay, when we want standard form, we multiply it out. All right, let's look at another one. So even though there's radicals, you still do it the same way. You would do it the same way if it's imaginary numbers too. So factored form. So it's positive square root of 5, which means I have to do x minus square root of 5, and then x plus square root of 5, and then x minus 4. Okay? That's factored form. Standard form, multiply it out. If you have to multiply it out and you have two that have radicals, those are the two you'd want to multiply first. Same thing as imaginary. If you have two that have imaginary, you want to multiply those first. Like it wouldn't, it'd be a lot harder if you try to do x plus square root of 5 times x minus 4. Okay, so do the two that have the radicals first. Okay, so x squared, then you get positive x times square root of 5, and then negative x times square root of 5. If you remember about conjugates, these were conjugates, so those middle terms end up canceling out, and then you have negative times positive, which is negative. What is square root of 5 times square root of 5? Just 5. So conjugates, it was a squared minus b squared, so x squared minus 5. Okay, times x minus 4. So what that is x squared minus 5. Okay, even though this is x squared, this is still a binomial. So I have a binomial times a binomial, which means I can FOIL again. So x squared times x is x cubed. My outer is negative 4x squared. The inner is negative 5x. And then negative 5 times negative 4 is positive 20. Okay. Any like terms? No. And is it standard form? Do my exponents go in order from greatest to least? 3, 2, 1, constant. Okay. All right. You can keep your notes out because I'm going to give you a quiz list. Questions about that? Tomorrow in the quiz, just factored form. Just this top form that's in red.